Okay, so let's just get right into it. We are in a totally new phase of AI. Seriously, it's moving way beyond being just a smart tool and becoming more like an autonomous partner, one that can actually plan and take complex actions all on its own. But as these agents get more and more powerful, this huge question pops up. How do we actually trust them?
Right, and let's dive into that with this core idea right here. The future of AI is agentic. Its success is determined by quality. But listen, quality here means so much more than just, does it work? It's really about building systems that are reliable, predictable, and at their core, trustworthy. And to do that, well, it's going to require a whole new way of thinking.
And this slide is the perfect way to understand why our old methods just won't cut it. Think about traditional software. It's like a delivery truck. It follows a fixed route, and if it breaks down, it's an obvious bug. Pretty straightforward. But an AI agent? No way. It's like a Formula One car. It is making dynamic judgments, split-second decisions in real time. You can't just run a simple checklist on it. You need continuous telemetry to understand the quality of every single one of its moves.
So, how in the world do we get that telemetry? Well, that brings us right to our first big challenge. We have to get inside the agent's mind. We have to be able to judge the entire process, not just the final result.
I love this analogy. It really clicks. A traditional system, it's like a line cook. They follow a recipe step by step. You judge them by the final burger. That's simple monitoring. But an AI agent, it's a gourmet chef in a mystery box challenge. It's creating something totally new from the ingredients it's given. So to judge its work, you can't just taste the final dish. You have to understand the process. Why did it pick that spice? What technique was it using? This is the huge shift from just monitoring to real observability.
And that is exactly what observability is all about. It's our ability to understand an agent's internal state, what's going on inside, by looking at the data it's creating. It is literally our window into the agent's thought process, letting us see how it got from point A, the prompt, to point B, the final action.
So, how do we actually build this window? Well, it stands on three technical pillars. First up, you've got logging. Just think of it like the agent's diary, writing down every single thing that happens. Then there's tracing, which takes all those diary entries and weaves them into a story, connecting the dots so we see the why behind the what. And finally, you have metrics. This is the final scorecard, rolling up all that data to give us a high-level report on the agent's overall health. Put them all together, and you get a complete picture.
Okay, so we figured out how to see inside the agent's mind. But what happens when that mind wants to, do something? This brings us to the next big piece of the puzzle, giving these agents hands so they can actually interact with the world through tools. The problem, and it is a huge one, is that connecting agents to tools right now is, well, it's a total mess. Imagine for every single new AI model and for every single new tool, like a search engine or a booking API, a developer has to sit down and build a custom one-off connector from scratch. This is what we call the N by M integration problem. N models times M tools. And it's an absolute nightmare of complexity that just does not scale. So what's the fix for all that chaos? Well, the industry is thankfully moving toward a universal standard. Instead of that mess, imagine a single plug-and-play protocol. It would basically act like a universal adapter, letting any agent connect to any tool with no custom coding needed. It's such a simple idea, but it brings order to incredible complexity. And that solution is actually taking shape. It's called the Model Context Protocol, or MCP. It's an open standard designed to do exactly what we were just talking about. Replace that fragmented, chaotic mess with a single, unified protocol for agents to find and use tools. It's a really elegant idea. But, and this is a big but, when you connect a powerful mind to powerful hands, you create a whole new set of dangers. This is where things get really, really critical. What happens when good agents go bad? Or maybe more importantly, are tricked into going bad? This leads us straight to the security risks. The first major threat is something really sneaky called tool shadowing. This is a security risk where a bad actor creates a malicious tool, but they write its description in a way that overshadows a legitimate one. The whole goal is to trick the agent into using the wrong tool for a very sensitive job. And this is a perfect illustration of how it works. On the left, you've got a legit tool for saving secrets to a corporate vault. Notice the very specific description. But on the right, there's a malicious tool with a much broader, more tempting description. So when a user just says, "Hey, save this," the agent looks at both and could easily get tricked into picking the malicious one, sending sensitive data straight to an attacker.
So the takeaway here is that agents can absolutely be deceived. And that brings us to our second major threat, which is a classic security problem that's now getting a new life in AI, the confused deputy. So what happens when an agent that has high-level permissions gets tricked into misusing its authority?
Let's just walk through this. The deputy is an AI agent, and it has high-level access to a company's code. An attacker who does not have that access gives the agent a tricky prompt, asking it to back up a secret file into a new branch. Now, the agent can't check the user's permissions. So what does it do? It uses its own high-level privileges to do exactly what it was asked, and in the process, it unknowingly leaks the secret code.
To put it simply, the agent gets tricked into becoming an unwitting accomplice. It misuses its legitimate authority, all on behalf of an attacker. It's a really powerful and subtle way to get around security protections.
So we've got these two massive challenges, right? We need to understand the agent's mind, and we need to secure its hands. To build any real sense of trust, we have to solve both. And that brings us to what we can call the architecture of trust.
And here is the absolute crucial point. Building trustworthy agents needs this dual focus. We have to have the inside view, that deep visibility from observability, and we need the outside view, a secure, standard way for it to use tools. But the most important thing to take away from all this is that these are not two separate problems. You simply cannot secure the agent's hands if you can't see inside its mind. They are completely, totally interconnected. You can't have one without the other.
And that really leaves us with this final, massive question for the future. If an AI agent can now think for itself and act on our behalf, how do we get beyond just making it capable and secure? How do we actually teach it wisdom? How do we make sure its judgment is always truly aligned with ours? That is the real challenge ahead of us.